I'm going to take a look at another example we did in class. So another equation in quadratic form, and because all I know how to solve are linears and quadratics, if it's got something like an x to the 6 and an x cubed, I might want to try and see if it's in quadratic form. So I'm going to take the smaller exponent, which is a 3, multiply it by 2, and see if that's 6. If it is 6, then it means it might be in quadratic form. So we're going to let u equal the smaller coefficient, not the coefficient, the smaller x cubed. And then u squared would be x cubed squared, which is x to the 6th. So x to the 6 is going to be u squared, so we're going to replace the x to the 6 with a u squared, the x cubed with a u, and 8 will stay as 8. This is now nice to factor. We're looking for a product of -8 and a sum of 7, so our factors should be positive 8 and -1. Go ahead and set each factor equal to 0. U will equal -8, or u will equal 1. Now we're interested in solving for x, not u, so we're going to go ahead and replace u with x cubed. So x cubed equals -8, or x cubed equals 1. So what's going to undo the cube is the cube root. So we're going to take the cube root of both sides, and the cube root of -8 is -2, and cube root of 1 is just 1. And we'll go ahead and check them and see what we end up getting. So plugging them in, we in fact get 0, so we get a happy face and a check mark because we've done it correctly. And we'll go ahead and plug in the other one, and of course we get a nice is equal to 0, so again check mark, smiley face. Okay, so let's look at another one. X to the 8th minus 5x to the 4th, I think, plus 6 equals 0. We're going to check the smaller exponent. Twice the smaller exponent is in fact the larger exponent, so that's good. We'll let u equal x to the 4th. U squared will be x to the 4th squared, which is x to the 8th, so that looks good. I'm going to go ahead and replace x to the 8th with u squared, x to the 4th with u. 6 will stay 6. We'll go ahead and factor this one. This one factors nicely. Product of 6 and a sum of -5, -3 times -2 will work for us. Okay. We'll set each factor equal to 0. U minus 2 equals 0, or u minus 3 equals 0. And we'll get u equals 2 and u equals 3. We don't want to solve for u, we want to solve for x, so we'll replace the u's with x to the 4th and x to the 4th. So what undoes a 4th power is going to be a 4th root, so we're going to take the 4th root of both sides. Now we didn't do this on the last one, but if you take square root, 4th root, or 6th root, we'll get plus and minus, because both plus and minus will work. When we square something that's plus and minus, it's just positive. If we 4th power something that's plus and minus, it's still just positive. If it's cubed or 5th power, odd power, then we don't need the plus and minus. Okay, so x is equal to plus or minus 4 root 2, or x is equal to plus or minus 4th root 2. If we check, because of this fact, the plus and minus doesn't matter when we do 4th power, 8th power, because we all have 4 negatives multiplied together, which is a positive, or 8 negatives or positives multiplied together, which is still positive. So we'll go ahead and check those. And when we substitute those in, so the 4th root of 2 to the 8th power means 4th root of 2 times itself 8 times. So we'll have a pair of 4 root 2's, and another, we'll have 4 of a kind and 4 of a kind. So 4th root of 2 to the 8th is going to be 4, minus 5 times 2 plus 6, that's equal to 0. And we'll go ahead and change the other one. Looks like I made a mistake there, so this should have been a 3 right there. We'll plug that in also, and it in fact works out quite nicely. So again, they both worked out, so we get a check mark and a smiley face because we've done them correctly. Okay, so notice this was 8th degree polynomial, and we got 4 roots. Sometimes we have less real roots. Let's do another one. And this one has a greatest common factor of x squared, so we're going to factor that out. And then x squared minus 1 is a difference of squares. So we get x squared times x minus 1, x plus 1 equals 0. We'll set each factor equal to 0. And then we'll go ahead and solve these. To undo the square, we take the square root. Square root of 0 is 0. Doesn't matter about plus and minus. I'm going to say it has multiplicity 2, because we did get a plus and minus, and it's kind of counted twice, but plus and minus 0 is just 0. So we'll talk about multiplicity later on. And then our other answers are 1 or negative 1. I'll let you check that one on your own. It's pretty easy to check, but they'll both work out just fine. The last one, x cubed minus 3x squared minus 4x plus 12. Has 4 terms, and usually what we want to do is we want to do factor by grouping. So we'll try grouping the first two, and their greatest common factor is 3x squared. We'll factor that out. And when I factor that out, 3x squared times x minus 3. The second two folks have a 4 in common. But I want to factor out a 4 so that the x minus 3's match up. So negative 4 times x minus 3 quantity equals 0. We have x minus 3 in common. Leftovers are 3x squared minus 4. We'll set each factor equal to 0. X is equal to 3, or. And then this second piece is going to take a little bit longer. So it's a quadratic. Not going to factor. You could use the quadratic form if you'd like. I'm going to go ahead and use the square root property. So we're going to add 4 to both sides. And then I'll divide by 3. Okay, and I'm going to take the square root. So I take the square root of both sides. So I get plus and minus 4/3. Now at this point in time, I'm going to rationalize it. I don't want to spend a lot of time in class talking about rationalizing. You can just give me the decimal approximation, but I'm going to go ahead and rationalize it for you. So we get plus or minus 2 root 3 over 3. Again, I'm okay with you just giving in the decimal on that. We'll not spend too much time about rationalizing. Okay?